Thanks for coming. My name is Jeremy Bos. I'm an assistant professor in electrical computer engineering. I want to start the talk by asking you a question. So how safe would an autonomous vehicle need to be for you, or maybe we'll put it in a different way, you put your loved one in an autonomous vehicle? So we'll see a show of hands. So let's say as safe as the average American driver, considering that you might consider yourself either better or worse than the average. Anyone? How about 1%? 1% safer than the average American driver. Tim, right, that's great. Okay. 5%. All right, 10. Twice as safe as the average American driver. 10 times safer. I think we've got almost everyone. All right. Well, let's just start then by the very lowest of these. 1% safer than the average American driver. At 1% safer, we would save 20 million gallons of gasoline. $10 billion in property damage and lost productivity. 50,000 accidents, 20,000 injuries, and 360 lives. And as pointed out earlier, if you go to full autonomy at full safety, the potential is up to saving nearly 30 or 34,000 lives, depending on who you ask. So that's obviously something, just 1% safer, we can do this. Obviously, if you just look at the numbers, it's something that everyone would say we have to do. So but the first thing we have to ask ourselves is, what do we mean by safe? Well, you could ask, so this is every year, by the way. Right? How do we define safe? Well, so Toyota's Gil Pratt says that a safe would be, and this is where he thinks we might be able to get 1 accident or 1 incident per vehicle every 200,000 miles. You could also use the automotive safety integrity level of D, which is used for safety critical devices, which says that you'd have 1 incident every billion hours of operation. Assuming an average speed of 45 miles an hour, that provides us with a mile, 45 billion incident-free miles. Is that a lot? Yes or no? Yes. Interestingly, 3.148 trillion miles are traveled on U.S. roadways every year by you and me and everyone else. That's only 1.45% of miles traveled annually. So if I want to prove autonomy, I really actually need a very small number of vehicles. I'm using these assumptions, which is a straw man that I'm going to get down very quickly. 1.45%, no problem, we can do that. Except here's the problem, and we all know this. Not all miles are created equal. Where autonomous vehicles are being developed and how they're being used is much different. By the way, this is on Bridge Street, this is right down the street from my house. So yeah, not all miles are created equal, right? So we need to design cars to account for these corner cases, and we're currently not even getting close to doing that. So this just talks about how we're designing autonomous features in cars. The second thing we need to talk about is where we are at. So on the left is a table that's compiled by the California Motor Vehicles, so the Department of Motor Vehicles, indicating the number of disengagements by autonomous companies are engaged in testing autonomous vehicles in the state of California. And you see that everyone has disengagements unless they're not actually currently operating in California. This gets worse if we do go to Pittsburgh with Uber. Not a single one of Uber's, at least the last I heard, demonstrations did not involve it in disengagement. So the driver has to interfere. And part of this is because the tools that we're developing, these autonomous, the artificial intelligence algorithms that make this possible, they run on commodity hardware. This is not hardware that any automaker would clear for production release. They're not functionally safe. And the result is, of course, the whole joke of wanting Windows running on your computer, that you may have crashes and the like. So that's what I'm interested in. I'm interested in trying to solve these problems, what I call autonomy at the end of the earth. So we are Huskies. This is our thing to own. We have more poor weather probably than any other major college in the United States at the very least, right? This is a problem we can tackle. We also have experience doing things like functional safety. So I'm interested in trying to explore solving these problems using VDEX data sharing, understanding vehicle dynamics, or how predictive vehicle dynamics based on sensor data might help us, again, provide increased mobility, functional safety, sensor fusion, estimating, predicting what the surface conditions are going to be like based upon big data and the like, and also pathfinding. This is enabled by Robotic System Enterprise. We also applied for SAE Auto Drive Challenge, and of course KRC is a big help.